In this I am explaining trigonometric chapter exercise 8.3. This fourth bit all these solve by using means prove that by using the identities. These I am doing. You can see and understand them. So what we should prove, always start with LHS, try to prove RHS. Okay, in some cases it is not possible. We should do LHS and RHS separately. You will get the same answer for some sums. Okay, so in this sum I am starting with LHS. So cosecant theta, so you observe the RHS part, it is in cos theta. So converts cosecant into 1 by sine. Cot theta means cos by sine, you try to convert. Okay. So LHS implies I am starting with the LHS and getting to prove RHS. Okay, cosecant theta minus cot theta whole square. Okay, I am taking this. So just substituting what is cosecant theta means 1 by sine theta. This is cos theta by sine theta. Okay. Next I have to apply. So next take LCM. So sine theta is the common denominator. 1 minus cos theta. Next apply square to both the denominator and numerator separately. So just I explained in the earlier video what is sine square theta is 1 minus cos square theta, that I am substituting here. Sine square theta is 1 minus cos square theta. So this is a minus b whole square. This is a square. 1 square is 1 only minus b square. So denominator you convert in the form a square minus b square is a plus b into a minus b. 1 minus cos theta into 1 plus cos theta. Okay. You convert like this. So 1 cos theta, 1 cancel. You will get 1 minus cos theta by 1 plus cos theta, which is required RHS part. Okay, just you start with LHS and what is cosecant theta you write. So observe the RHS, you try to make changes accordingly. So cot theta is cos theta by sin theta. Just take LCM and write the numerator as it is, and next thing is you can apply square, and sin square theta is 1 minus cos square theta. So I wrote in the manner a square minus b square is a plus b into a minus b. So one term get cancelled means you will get the RHS part. This is about the first sum. So next coming to second sum, this one you should prove, 2 secant a you should prove. Okay, so just I am taking the LCM of the denominator. So what is LCM? 1 plus sin a into cos a is the LCM. So just this like this, cos square a into 1 plus sin a whole square in the numerator. So by numerator, this one you do it by a plus b whole square, this term. So this term you write as it is. Okay. So cos square a in plus a plus b whole square is a square, 1 square is 1 only, plus 2ab means 2 sin a, plus b square is sin square a. Okay. So denominator no change, you should write as it is, 1 plus sin a into cos a. Sorry, I wrote theta here, a. So this one you observe, cos square a plus sin square a is 1 by using the identity. So 1 plus 1, 2 you will be getting. 2 plus 2 sin a. Okay. So denominator write as it is. Then next term is take 2 common. 2 common means 1 plus sin a will be getting in the numerator. So both 1 plus sin a cancels. Okay, this term cancels. So 2 by cos a means you will be getting 2 by cos a is what? 2 secant a. 1 by cos a is nothing but secant a. Okay, this is about the second one. This is first one. Okay. Next, third one. Say observe this is the third one. So we should start LHS, prove 1 plus secant theta into cosecant theta. Okay. So I am converting tan to sin cos. Okay. Both cot also. And then take LCM, you should simplify. Okay. Sin theta by cos theta. Cot theta is 1 minus cos theta by sin theta. Just I am doing the conversion. Cos theta by sin theta by 1 minus sin theta by cos theta. Now just what we should do, denominator take LCM and a reciprocal, those terms we should do. Okay. So sin by this cos comes the numerator. Okay. So I took LCM as this here multiply, and next term we should reciprocal them. Sin theta minus cos theta by cos sin theta. Okay. Here this sign I am writing here. Okay, same manner we should write. This sin theta comes to denominator. Now this part we should take LCM. Cos theta minus sin theta by cos theta. So this will reciprocal next. It will go to numerator. Same manner this. Okay. So next you observe here you have sin theta minus cos theta. Here cos theta minus sin theta. I am taking minus common for this. So just observe cos theta minus sin theta is there, no? So I am taking minus 1 common. Okay. What will happen? This term comes first minus sin theta. Next you multiply minus sin theta plus cos theta. So same term we will be getting. Okay. You understood the step. Next sin square theta. This term no change. Minus because I took minus outside. So cos square theta sin theta minus cos theta. You understood now? Here I took minus 1 common so that here this term and this term matches. Okay. Now we can take again denominators LCM. Okay. What will happen? Sin theta, cos theta and this term. Sin theta into cos theta into sin theta minus cos theta. Okay. This is LCM. Now just observe the denominator. This term we have. So what term not there? Sin theta. So we should multiply numerator with sin theta means sin cube theta. Here also this term is there. So what term is not there? Cos theta. So cos cube theta. So numerator in the form you observe a cube minus b cube. So what is the formula? A minus b into, so I am just writing here, a cube minus b cube is, so first term you will get minus a minus b into a square plus ab plus b square. Okay, that's the formula. Okay, this is the formula. So according to that I am explaining. So first term is minus, next term is all plus sin square theta plus sin into cos plus cos square theta. So these two you will get 1. Okay. So as a denominator you should write as it is. Sin theta into cos theta into sin theta minus cos theta. So just observe 1 plus, so this term will get cancelled. 1 plus sin theta cos theta. Why we got 1 means, since by identity sin square theta plus cos square theta equal to 1 by sin theta into cos theta. So just I am writing the denominator separately to the numerator. So 1 by sin theta cos theta plus sin theta cos theta by sin theta cos theta. So these both will get cancelled. You will get 1 here. So 1 by sin means cosecant, 1 by cos means secant. So what is the see RHS part you observe? So secant theta cosecant theta plus 1. See, addition is always a commutative. You can write this manner, 1 plus cosecant here, secant theta into cosecant theta. Okay, I hope this one you understood clearly. This is the identity. This is the formula used. Okay, so important sum, just convert the given terms into sin and cos, take the denominator LCM, and here I took -1 common. Okay, and then apply a cube minus b cube formula here by identity. See, fourth sum is this, 1 plus secant A by secant A equal to sin square A by 1 minus cos A. Simplify LHS, RHS separately. So, if you simplify LHS, RHS separately means both you will be getting one answer. Okay. So, LHS I am doing now. LHS means 1 plus secant A by secant A. So, I am converting into cos means 1 by cos A, secant A. So LCM take means 1 plus cos A, 1 plus cos A plus 1 by cos A, here 1 by cos A. So in both this and this cancels, you will get answer as 1 plus cos A. Okay, this is LHS part. So what is RHS? So sin square A means I already told you it is 1 minus cos square A. Since by identity, see, sin square A plus cos square A equal to 1. Okay. So sin square A means you transpose this to RHS. Okay. So 1 minus cos square A by 1 minus cos A. So this is the numerator in the form of A square minus B square, which is A plus B into A minus B. So one term in the 1 minus cos A will get cancelled. Will be answer is 1 plus cos A. Okay, this is fourth sum. So LHS, RHS for this sum should simplify separately to get the required answer. Next, coming to this sum, we should prove cosecant A plus cot A. So by using this identity, we should prove. So what we should do first? Both numerator and denominator I am multiplying with 1 by sin A. Okay, 1 by sin A into this full. So each term this sin A will come, cos A by sin A, next minus sin A by sin A, 1 by sin A. So like that, if you simplify means cos A by sin A means cot A, okay, minus sin A by sin A means 1, plus 1 by sin A means cosecant A, okay, cos by sin means cot A, okay, plus sin A by sin A means 1 minus cosecant A, okay. Okay, next you observe this one. Okay, so instead of 1 I am writing cosecant square A minus cot square A. Okay, so what I did, cosecant square A minus cot square A equal to 1. Okay, I am substituting. Instead of this numerator 1, I am substituting this. See, cosecant A plus cot A, you write this. Minus, so instead of that one I am writing cosecant square A minus cot square A. So denominator same you will be writing. This is numerator I am simplifying. Okay. So I am just not writing denominator. So this is a square minus b square means a plus b into a minus b. Okay. So cosecant a plus cot a I am taking common from this. Okay, this term I took outside. Okay. So this came out means 1 will be remaining. So a plus b into a minus b means a minus b will be remaining. Cosecant a minus cot a. So next time minus into minus plus you will get. Okay. Cosecant a plus cot a. Okay. So 1 minus cosecant a plus cot a. By full this thing you write 1 plus cot a minus cosecant a. So you just observe both these terms. 1 minus cosecant a plus cot a, 1 plus cot a, 1 plus cot a minus cosecant a. These two same. So we got the required answer. Cosecant a plus cot a is the answer. So that is nothing but RHS. That is equal to RHS. Hence proved. Okay. This is about the fifth sum. Next, coming to this, we have to rationalize both the numerator and denominator with the root of 1 plus sin a. Okay. So a plus b, root of a plus b, root of a plus b means root of a plus b whole square. Square root of 1 minus sin a into 1 plus sin a. So a plus b into a minus b means a square minus b square in the denominator. Square root cancels 1 plus sin a by root of 1 minus sin square a. So root of 1 minus sin square a means by identity this is cos a. Why? Since cos square a equal to 1 minus sin square a, cos a is nothing but root of 1 minus sin square a. Now you separately write the cos a to the numerator. Each separately you mention means you will get the required proof. This is secant a plus tan a. It is nothing but the RHS. So what it is rationalizing both numerator and denominator. Why we do rationalizing means to remove the irrationality. Okay. See why we should do means if you rationality if you observe means the same term if you apply means if you multiply means we can remove this irrationality in the denominator. So root 2 into root 2 means 2. So same manner we did the simplifying here. Next, coming to the seventh sum. See this LHS equal to, we should prove tan theta. So observe sin theta you take common, cos theta you take common. Sin theta equal to, sin theta I took common means 1 minus 2 sin square theta. Here cos theta you take common means 2 cos square theta minus 1. So any one you should change. Either this one you change into cos or this one you should change into sin. Any one. One thing we should do. Both you should change means they will both converted to cos and sin. No changes. So I am converting this to cos. Okay. 1 minus 2, 1 minus cos square theta. Okay. So denominator as it is we should write. So this is tan theta. 1 minus 2, 2 into 1, 2, minus into minus plus. So 2 cos square theta minus 2 plus 1 is minus 1. So 2 cos square theta minus 1 by 2 cos square theta minus 1 into tan theta. So you'll get the required answer. Tan theta you'll be getting. This get cancels. This is the 7th sum. Next, 8th sum. See, by using a plus b whole square you should expand, then you should get the required proof. Tan square theta plus cot square a, tan square a plus cot square a plus 7 you should get. So just by using a plus b whole square, sin square a plus 2 sin a cosecant a plus cosecant square a. Okay. Same manner you do this. Cos square a plus 2 cos a secant a plus secant square a. So we know that cosecant a means 1 by sin a. So these both will get cancelled. Cos a and secant a are reciprocal to each other. They will get cancelled. Sin square a plus cos square a equal to 1. Okay. So you can write next step if you want. Just clubbing you do. Okay, 1. Okay. Next, here 2 plus 2, 4. Okay. So the remaining you write as it is. This is 1 plus 4, 5. So answer you observe it is in tan and cot. So convert cosecant square a is 1 plus cot square a. Secant square a is 1 plus tan square a. So 5 plus 1 means 7 plus tan square a plus cot square a. Okay. So what are the identities used here? Cosecant a equal to 1 by sin a I used here. Okay. Next, secant a is 1 by cos a. Okay. Next, cosecant square a is 1 plus cot square a I used. Secant square a is 1 plus tan square a. That also you should write. Okay. Till here only proof. Okay. This is the 8th sum. So next sum is this. You should prove this one. So cosecant a means 1 by sin. Secant a in 1 by cos. I took LCM means 1 minus sin square a. 1 minus cos square a. 1 minus sin square a is cos square a. 1 minus sin cos square a means sin square a. So both 1 term cancels. You get sin a into cos a. So denominator you have 1 means sin a into cos a by 1 you should write as sin square a plus cos square a. Okay. So you bring this numerator to denominator. So 1 by sin a cos a. Okay. So each term you write separately. Sin square a by sin a cos a plus you will get sin by cos में tan a plus cot a. Okay, this is the required proof or HS. Next, last sum, you should simplify this and this you should get tan square a. So just to convert cot a is 1 by tan. Okay. Take LCM. So a plus b plus a both are same because identity, because addition is commutative, so both cancels. Next, coming to this. Tan a. So you will get 1 minus tan a by tan a minus 1 to tan square a here. This is whole square. Okay. So what you will get here, you take minus common in this, means both these terms get cancels because square is there. Tan A whole square by minus you take common and square, minus 1 square means minus only 1 only. So both cancel, this is plus 1, you will get answer as tan square A. Okay, this is the last sum of this identities. Very important, all are.